Okay, so hi everyone. So welcome back to yet another video. So today in this video I will be explaining you about this problem Mad City, which was asked in Div 4 Codeforces round 898 and it is rated 1700. So the problem reads like this, that Marcel and Valerio are in the Mad City, which is represented by n buildings with n two-way roads between them. So there are n cities in total, and there are also n two-way roads between them, right? So the road is undirected or bidirectional. So Marcel and Valerio start at building A and B respectively. So in a city, in this mad city, Marcel is at the building A and Valerio is at the building B at time equal to 0, and Marcel wants to catch Valerio. So you can imagine, like, Marcel is the police and Valerio is the thief, and that's why Marcel wants to catch Valerio for some reason. In other words, be in the same building as him or meet him on the same road. So Marcel wants to catch Valerio somehow. Maybe they can meet up in the same building or in the same road. During each move, they choose to go to an adjacent building of their current one or stay in the same building. So each amount of time they have a choice that from the current building they can either move to the other building or can stay wherever they are. Because Valerio knows Marcel so well, that is, the thief knows police, right? So Valerio can predict when Marcel will go in the next move. So the thief already knows that what move that does the Marcel will play. So accordingly he will also choose his next move, right? So Valerio can use this information to make his next move. So they start and end this move at the same time. So the time during which this Marcel, that is the police, is moving, during that same time only this Valerio will also be moving. So they will not be moving like one after another. They will be moving simultaneously wherever they are moving, right? So it is guaranteed that any pair of buildings is connected by some path, and there is at most one road between any pair of buildings. So since it is written that any pair of buildings is connected by some path, so it means that the graph is completely connected, it is not disconnected, and there is at most one road between any pair of buildings. So yes, the graph is connected. Assuming both players play optimally, answer if this Valerio, that is the thief, can escape this police for infinite time or not. So in the input we are given first the number of test cases, and then we are given, and in the next line we are given for each test case 3 integers, that is n, a, b. N represents the total number of buildings, which is also equal to the total number of roads, and this a is the starting building of Marcel and this b is the starting building of this Valerio. So the next n lines contains u and v, that is the description of the roads, and this will help us to build the actual graph, right? And it is bidirectional, so u is connected to v and v is also connected to u, and n can go till up to 2 into 10 to the power 5. Okay, so the roads are given in such a way that it is possible to get any building to any other building. Okay, so what we have to output, so we just have to output yes or no, whether Valerio can escape Marcel for forever or not, right? So we have to print that accordingly. So here we are given 6 test cases, so we will discuss few of the test cases, right? So let us now understand these test cases in the blackboard itself. So this is the very first example given in the problem statement. So in this example there are a total of 3 cities, that is n is equal to 3, and so there are 3 roads also, that is m is also equal to 3. So 3 cities and the 3 bidirectional roads between them. So initially the police, that is Marcel, is present at the second city. So Marcel is here, right? And the thief, that is the Valerio, is present on the city first, that is Valerio is here. So let me mark this properly. So Marcel is present in this second city and Valerio is present on this first city. So since in the question it was told that Valerio already knows that what direction or in what road this Marcel will be moving. So suppose Marcel decided to move from the this second city to the first city, right? So it will move like this. So the time when he started moving from the second city to the first city in order to catch this Valerio already knows that he would have started moving from the second to the first. So what he could have done is he would have just simply moved from this first city to this third city in this way. So by the time Marcel would have reached here, Valerio would have already have gone till there. So in this way, Valerio would have escaped Marcel, right? So again, if Marcel decided to catch Valerio, so he would have moved from this cell, that is this city, to this city in this way. So Valerio will again know that Marcel is coming through this road to catch him. So what he will do is he will simply again reach here and Marcel will go here. So Marcel would have come here and Valerio would have gone there, right? So he can do this for infinite time, isn't he? So we can say that Valerio can escape Marcel for forever in this example. So we have to print yes, right? So we will just print yes. Now let us discuss another example. So this is another example given in the problem statement. So in this example, there are a total of 4 cities in this case, and there are by also 4 roads, right? So this is the first road, second road, third road, fourth road, and so first city, second city, third city, fourth city, right? So initially in this example, Marcel is present on the first city while Valerio is present on the fourth city. So as you can see that since Marcel is the police, so what he want to do is he want to catch Valerio, right? So in order to catch Valerio, he will try to move towards Valerio. So suppose Marcel decided to move from this city till this city. So when he was moving from the first city till the fourth city, Valerio knew that he was coming towards him in order to catch him. So he will want to escape, right? He will not want to stay wherever he is, right? So where does this Valerio can go now? So if you see carefully, then Valerio has only one option, that is he can go from this fourth city till this first city through this road, right? So suppose Valerio start moving from this city through this road, and when he was moving, Marcel was also coming through this road, and suppose they meet up at this point. So in the question it was clearly written that Marcel and Valerio, whenever they meet on a common city or on a common road, so he will catch him no matter how, right? So that's why in this example, this Marcel and Valerio will meet each other at this point, and hence Marcel will be able to catch Valerio and he will not be able to escape now. So that's why the output for this test case is a no. So I hope you understood why for this example the answer was yes, and for how this example the answer is no. Now let us discuss another example, and in that we will be considering more number of cities in order to understand it better. Now let us consider another example given in the test case. So for this example, n is equal to 7, a equal to 1 and b equal to 1. So what it means is initially both Marcel and Valerio are together present on the same city. So we don't have to do anything, right? Because they are already present on the same city. So Marcel will easily catch Valerio, because in the question it was given that whenever they will be present on the common node, that is on a common city, right? So in that case Marcel will easily catch Valerio. So that's why since they are present on the same node initially, so Valerio will not be able to escape Marcel this time, and hence we will print a no, right? So for any test case, if you see, then it would be better for us if we initially check that if a is equal to b. If a is equal to b, then we don't have to do anything, right? We just have to print no in that case. Now let us consider this example. So in this example, n is equal to 8, that is total 8 cities are present from 1 to 8, and also n roads, that is 8 roads, and initially Marcel is present on the 5th city while Valerio is present on the 3rd city, right? Marcel is on the 5th and Valerio is on the 3rd. So as you can see that Marcel wants to catch Valerio, right? So what he will do, he will always try to move towards Valerio and not away from him, right? So suppose Marcel from this city started moving towards this road in to reach this city, and then he will move towards this city, then through this, and he will try to go towards Valerio as soon as possible, right? So since Valerio already knows what direction Marcel will be moving, right? So he will also want to escape Marcel in that case. So initially, since Valerio is present on this city, so he has only one choice, that is he will move towards this road in order to reach this city, and then he will decide whether to go through here or go through here, right? So suppose now Marcel moved from this city till the first city, and also Valerio from the third city till the eighth city. So now Marcel is here and Valerio is here, right? So now what will happen? They will make one move more. So Marcel will definitely move from the first city till the second city, right? So Marcel will go from the first city to here. But now, if you look, then Valerio has two choices. He can either go from the 8th city till the 4th city, right? From the 8th city till the 4th city, or from the 8th city till in this road in order to reach 6. So, definitely, if you clearly see, then if Valerio goes from the 8th city for the 4th city, then he can't go anywhere else in that case. So, why he will want to go to the 4th city? He will not want, because in that case, he will just got stuck in that case, right? So, that's why this Valerio from 8th city will go to the 6th city. So that's why Valerio will go from this 8th to the 6th. So now Valerio is here. Now if you see, then Marcel is here and Valerio is here, and they still have not met yet, right? So now what Marcel will do, Marcel will try to go towards Valerio. So that's why Marcel will go from this second city in this sixth city. But since, as I already said, that Valerio was already knowing that what direction Marcel will be moving, so what Valerio will do instead, he will just move from this sixth city in this seventh city. So again, if you see, then Valerio has escaped Marcel, and now if you try to look carefully, then you will realize that now Valerio has escaped Marcel indefinitely. Why? Because suppose Valerio now moves from the 7th to the 5th city, then what Marcel will do? Marcel will either go to the second city or till the 7th city. So suppose Valerio goes from here. So Marcel has two choices now. He can move like either here or either here, right? So uh, wherever he goes, he cannot catch Valerio now, because he would always be having a choice of moving to an adjacent building that Valerio that is Marcel can't reach at that instant, right? So we can say that Valerio has now escaped Marcel forever, right? Suppose Marcel reached here and Valerio is here, then Marcel will go here, then Valerio will go there, and again Marcel will go here, then Valerio will again go there. So they will never be able to meet now, and that's why we can say that Valerio has escaped Marcel for infinite time. So now you must be thinking, okay, since Valerio has escaped Marcel, so that's why for this example the answer should be a yes, right? But but if you look in the original test case output, so it was this example, right? Fifth example, and for the fifth example the answer is a no. So why the answer for this example is a no and not yes? So it means this is wrong. The answer is a no. So this happened because initially, if you realize, let me draw the initial condition again. So this was the initial graph, right? So what I did was I moved this parcel through this path. Like he moved from here to here, then from here to here, and then from here to here. So he used this path instead of this path. So since he is a police and he knows every route very well, so he will always want to reach Valerio as soon as possible. That is, he will always want to utilize the shortest path and not the longest one or the longer one, right? So as you can see that he can reach from this fifth city to the sixth city through two steps, that is through this road and through this road. But this path was taking him three roads instead of this two, right? So that's why Marcel will try to reach from 5th to the 7th and then from 7th to the 6th instead of this path. So now if you try to again simulate the problem, then again Marcel will move one step and Valerio will also move one step. So Valerio from one step will move here and Marcel will reach here. And again they will move one step. So again Marcel will reach here. And again if you see, then Valerio from this city can either go to the fourth city or back to the third city or the sixth city. So if he tries to go anywhere, like he tries to go to the third city, then what will happen? This Marcel will enter this part, right? And in that case Valerio will not be able to escape. So if you see, if Valerio decided to go in this fourth city, suppose, so Valerio decided to go here, so in that same time Marcel will go through this route in order to reach here, and now Valerio cannot escape. So Valerio has been cached, right? So he cannot escape. Or what can have happened is Valerio would have gone from this 8th city to the third city back, and in the same meantime Marcel would have reached this city. So again Valerio cannot escape Marcel and he is cached, right? Or what could have happened is Valerio from this 8th city could have gone to the 6th city, right? And if you knew, then Marcel was also present at the 6th city only. So what has happened? So they would have met somewhere in between. That is, both Valerio and Marcel would have met on the same road in the middle. So in this way, Marcel would have cached Valerio, right? They would have both met here. So that's why no matter how hard Valerio tries, he cannot escape this time, right? And since in the question it was given that both players try to play optimally, it means that both would have been giving their best. So Valerio is also giving his best every time to escape, while Marcel is also giving his best every time in order to reach Valerio in the shortest path as possible. So that's why for this example the answer is a no instead of a yes. Hope you understood these four examples very clearly, and I think these four examples are more than enough to make you understand the problem completely and to come to a particular solution. So if I now tell you or ask you to think about the logic that we will use here while coding, so what we will be using or thinking. So as I told you that Marcel will always want to reach Valerio as soon as possible, while this Valerio will try to escape this Marcel as much as possible, right? So in the previous example, if you look, let us look at the first example. So in that case, what was there? Initially Marcel was on the third and Valerio was on the second, and in that case Valerio was already and in this case Valerio was always able to escape Marcel. Why? Because if you look, then they were both a part of a cycle, right? M was on third and V was on second, and they were a part of cycle. So no matter where Marcel would have moved, this Valerio would have always find a way to move in order to get escape from this police, right? So if both are a part of cycle, or rather we can say if Valerio is a part of a cycle and they are not present on the same city initially, then Valerio can always escape, right? And for this example, if you see, then Valerio was not a part of a cycle. So for this example, this is a cycle, right? This is a cycle, and 3, 2, 1 are the cities which are a part of cycle, and Marcel is a member of this cycle initially, but Valerio is not. That's why he was not able to enter the cycle before this Marcel and got caught. Similarly, if we look here, so here the case was simple enough, that is A is equal to B, that is they are already present on the same city, so it doesn't matter if they are present on the cycle or not, right? Since they are present on the city, he will get caught, and hence the answer is a no. But in this example, if you look, then you will realize that Marcel is a part of this cycle. So this is a cycle connecting 5 nodes, 5, 1, 2, 6, 7, and Valerio is not a part of any cycle. So as I just told you that in order to escape from Marcel indefinitely, Valerio will always want to just be a part of the cycle. So as soon as Valerio enters the cycle, and suppose Marcel is not present on the same node, so in that case Valerio would always be able to escape from anywhere to anywhere, right? So in that case Marcel will never be able to catch Valerio. Why? Because both are now a part of cycle and they will be moving adjacent, they will be moving to the adjacent cities continuously. That's why he will never get caught. So So that's why we will always want to make this value a part of the cycle, right? So now the question is, uh, from where this Valerio will enter the cycle. So if you see, then Valerio is present here initially, then has gone from this third till the eighth city, then from the eighth city till the sixth city. And this sixth is the first node that is a part of the cycle from where the Valerio is trying to enter the cycle, right? So what we will want is, and if you look carefully in the problem statement, then you will realize that since there are n cities and n edges, it means that the graph is already connected, right? And it was also mentioned in the question. And also one more thing to notice is that there would always be one cycle always present in the graph, and there would be at most only one cycle present, not two cycles. So since only one cycle will be present in the graph, so since only one cycle will be present in the graph, and if Valerio is present outside the cycle, then there would only be one entry point possible for this Valerio if he is present outside the cycle, right? So that's why Valerio will try to find out this much entry point, and he will try to enter from this entry point in order to be a part of this cycle, right? So now our task is very simple. We just want to find this entry point somehow, because if it found this entry point somehow and this Valerio is able to reach this entry point before Marcel, so he will be able to escape forever, right? So how we will find this entry point? This is the question now. So you see, so I believe that you must have studied the how to detect a cycle in an undirected graph, right? It is a very easy concept. So what we do? So we just start a DFS. So suppose our DFS call starts from the third city and it goes to the eighth city. Then from the eighth city the call goes to the sixth city. Then it has two choices. So suppose it goes from this sixth city to the second, from the second city to the first city, then from the first city to the fifth city, then from the fifth city to the seventh city, and then again it tries to come to this. But in the visited array we would have already marked this as visited, because when it came to this city from the eighth city we already marked it visited, right? So since it is already a visited node and it is not its parent, because the parent of 7 was 5 and not 6, so it is a neighbor which is not a parent and is already visited, so it means that we have detected a cycle successfully at this point. Since we have detected a cycle at this point, it means that this is our entry node from where Valerio would try to enter. So this is our entry node, right? So that's why Valerio will want to reach this sixth node as soon as possible, and also Marcel will also try to reach sixth node as soon as possible, because this is the threshold thing, right? Because both Valerio and Marcel has a concern for this sixth node, because both wants to reach this as much as possible, because this is the only node which is deciding whether Valerio will escape Marcel forever or not, right? So that's why we will want to reach, that's why Valerio will try to reach this entry node as soon as possible. So what we want now, we just want to calculate the distance from where Valerio is currently present till this entry point node. So what was our first task? So I think we have done our first task already, that is we have already calculated the entry point, right? That is what is the entry point in this graph. And after finding the entry point, I wanted to calculate the distance of both this Valerio and Marcel to this entry node. So the distance of Valerio till this entry node is what? So this is 1 unit, this is a 1 unit, so total 2 units. So the distance of Valerio from his initial location to this entry node is 2, right? So for Valerio it is 2, and for Marcel, so for Marcel if you see, then he can have either moved from 5th to 6th through this path or through this path. So as I already told you that if he tried to move from this path, then it would cost him a total of 3 steps, but he could have done it better if he had moved from this path, and in that case he would have only used 2 costs. So for that case I can say that Marcel could have used a 2 cost also, right, in order to reach from the 5th city to the 6th city. So as you can see now, both so as you can see now, both Valerio and Marcel have reached 6th city at a minimum of 2 steps. So What does it mean? It means that Valerio can reach 6th city by at minimum using a 2 step. Similarly, Marcel can also reach this 6th city by using a at least of 2 steps. So it means that they both will reach simultaneously to this node, right? They both will reach simultaneously. And since they will reach simultaneously, it means that Valerio will get caught by this Marcel at this node and will not be able to escape. Let me modify a graph a bit. So suppose there was a fifth node, right? It was there present initially, but what I am saying is along with this fifth node, let's take another node, say ninth node, right? So it is also present now, right? So that's why now there are total of 9 nodes and also 9 edges. So now in this example I have taken 9 nodes and total 9 roads, right? So initially Valerio is present on third city, and suppose now instead of the fifth city, Marcel is present on the ninth city. So Marcel is present here. So now Valerio has nothing changed for him. He will again be using 2 step only in order to reach the entry point. But for Marcel, things have changed. So in order to reach from the ninth city to the sixth city now, he will use either this path, which will cost him a total of 3 steps, or this path, which will again cost him a total of 3 steps. So in any case, he will be using at least of 3 steps in order to reach from the ninth city to the entry point. So now you can see that Marcel is reaching to the sixth city, that is the entry point, in 3 units of time. But Valerio is reaching the same node in 2 units of time. That is, Valerio is reaching earlier as compared to the Marcel. So we can say that suppose what could have happened is on 2 units of time, Valerio would have been present here and Marcel would have been present either on this node or either on this node. So if Marcel was present on this node and he tried to move from here to here, then at the same time Valerio would have gone from here to here, right? But if Marcel was present on this node, he would have tried to go to there, then Valerio would have simply gone from there to here, right? So that's why we can say now Valerio has escaped the Marcel indefinitely, and that's why for this example the answer would have been a yes instead of a no. So I think it has become to you very clear by now that what is the main thing that we are applying. So we are just trying to find out the entry point first, and we are just checking whatever mass, and we are just checking whosoever, that is Marcel and Valerio, is reaching this entry point first. If somehow Valerio is able to reach this entry point first before Marcel, he will become a part of the cycle, and since he will become a part of the cycle, he will always be able to escape Marcel no matter what. So that's why in the second step what we will do is we will try to calculate the distance, that is calculate distance of Marcel and Valerio from their initial position to the entry point, right? And if distance of this Valerio is less as compared to the distance of this Marcel, then we can say that Valerio has reached the cycle before, so he is a part of cycle now and he can escape wherever he wants. So that's why answer would have been a yes for this case. Otherwise we will say that else the answer would be a no. That is, either Marcel will reach the entry point, look here, either Marcel will reach this entry point at the same time as the Valerio or before the Valerio. So in that case the answer would have been a no, right? So now the final question is how we will calculate this entry point first. So as I just told you, we will just use the concept of detecting a cycle in an undirected graph. So the DFS call start will from here, go here, then here, then here, then here, then here, then here, then here, and then again it will go come here, and it will realize that this is not a parent and it is already visited, so this is the entry point, right? But there is one problem in this concept. What if Valerio was already a part of cycle and it is not present on the same node as the Marcel? So if Valerio was already a part of cycle, that is, he is already a part of cycle and not outside of it, that means he can always escape. But how we will know that he is already a part of cycle? How would entry point help us in that case? And in that case, if we also start a DFS call from this Valerio, then we will not be able to find this entry point anymore. Suppose now Valerio is present here and Marcel is present here. So I told you to, in order to find the entry point in the very first step, just start a DFS call from the value's location. So suppose I start a DFS call from the 7th location, right? So what will happen? The DFS call will go, suppose it goes to the 5th city, then from 5th to the 9th city, then from 9 to the 1st city, then to the 2nd city, then to the 6th city. Then it goes like here, it will cover these nodes, then it will again backtrack and will come here from where it started, right? So when it was coming here, it will realize that it is not a parent node, that is, it is a child and it is already visited. So instead of marking this as the entry node, it will mark this as the entry node. But we know that this is wrong. This is our entry node for the cycle and not this one. But still, if you look clearly, then you will realize that this will cause no problem in our logic. Why? Because in the second step we just wanted to find the distance of both of these nodes from the entry point, right? So now if you see, then what is happening? The distance of v, that is Valerio. So since this is marked as the entry point now, so the distance of v to the entry point, that is to itself, is 0. So this thing would be 0. And also the distance of Marcel to the entry point, that is from M to V, will have in 2 steps at least, at minimum, right? So it will be 2. So what we wanted that distance of V should be less than distance of M, right? So what is the distance of V here? 0. And what is distance of M? 2. So obviously 0 is less than 2, right? 0 is less than 2. And since 0 is less than 2, what will our logic do? It will just print a yes in this case. And we know very well that since Valerio was already a part of cycle initially, so we would have wanted to print yes, and this is the thing that is being done here already, right? So that's why our logic will work here correctly and will not fail. And one last thing that I want to tell you is how we will find this distance from the current location of the Marcel and Valerio to the entry point. So you can use any of the techniques, but I will be using just a simple BFS, right? So using BFS, I will be finding the minimum distance from the M and V to the entry point, right? So I'll be using a BFS, and before BFS, in order to find the entry point, if any, I will just use a DFS. So I'll just be using one DFS in order to find this entry point, and then I will be just using two BFS actually, in order to first find the distance from M to the entry point, and then from the V to the entry point. And once I have the distance of both of them, I will just compare them. If it is less, then the answer is a yes, otherwise the answer is a no. So now I think I have discussed everything that is required to solve this problem. So I think I should start writing my code now. So let us go to the code editor. So this is our required input and this is our expected output, right? So now, and if you see, then in the input we have to first take the number of test cases, then NAB, and then n lines of UNB. So test cases here, and then NAB, 3 integers, right? So NAB, and then after taking the inputs of NAB, I have to take the input of n lines, since there are n cities and n roads, as I just told before. So each line will contain 2 integers U and V, representing a bidirectional road between cities U and V. So I will just store them, suppose in a graph, say adjacency list like G of U dot pushback V, and then G of B, not B, it's V dot pushback U, right? So let me also declare this here. So vector of, it would be an adjacency list, right? So, and let me give it a size of n+1, so I'll be using 1 based indexing everywhere. And also if you see, then the inputs are also given in 1 based indexing only, from 1 to n. So okay. And now after the building the graph, what I just told you that if A is equal to B, that is they are already present on the same city, so he will get caught. So in that case I will print a no, right? And if it is not the case, so they are not present on the same city, so what I will do, I will just try to find the entry point first. So suppose I find the entry point like, let me declare this entry point here globally. So entry point, let me set it initially to -1, and every time this happens, for every test case, let me mark this entry point to 0 again, so the previous thing is not used. and I will just use a simple DFS call in order to find this entry point and from which point I will start my DFS. So as I told, I will always start my DFS from wherever the value is present, and the location of value is this bth node, right? So I will start my DFS from the bth node, and I will also be using a visited array, right? So I will also pass this visited array and the adjacency list. So now let me write down this void function. So void DFS int node and then the visited array, that is this, and then the graph, which is an adjacency list. So this one, right? So now let me also declare this visited array somewhere here. I think I should declare it inside, right? We have passed this the location of value, visited array, and the graph. And now let me write down this DFS function. So what we will do, it will first mark this node as visited, right? And then it will iterate through the child of this current node. And if it is let me also pass it through reference only, so it will be better and no copies will be made. So if this child is not equal to the parent, so I forgot to mark one thing, that is pass one thing, that is the initial parent of b. So initial parent of b is -1, let's say. So here I will be writing it as parent, right? So if this child is not equal to the parent, then it means that, but wait, I think instead in place of this I will first check if the child is already visited or not, right? So if this child is not already visited, then I will pass my DFS call to this, and what I will be passing, I will be passing the child and its parent is the node now, and visited would remain same and this graph would remain same, right? So if the child was not visited, we will call the DFS again, but if it is not the case, that is the child is already visited, so there are two possibilities. Either, since the graph is bidirectional, that is the child is either the parent or the real entry point. So if this child is not equal to parent, so if the child is not equal to parent, that is it is a neighbor and it is not the parent. So what is it? It is an entry point. So I will set this entry point equal to this child, and I will return it true because we don't want to go any further because we have already found our entry point, right? And since we are returning a 1, so I think I have to change this from bool from void to bool, and at last I will just return a false, right? So in this way we would have been calculating our entry point. So in this way now we have calculated our entry point, and now what we want to calculate the distance of both Marcel and Valerio till this entry point. So for that I just told you that we will use a breadth first search from both of them. So suppose I start my BFS call from first Marcel, which is present at the 8th location. So I will again be using the visited array, right? So and I will also be passing this graph, right? So I'll be doing this 2 times actually, one for the Marcel and this for the Valerio. Okay, and suppose after doing this we are able to find the distance of both of them, right? So where the distances will be stored, so for that I will be using another vector, let's say vector of distance, and it will also be of size n+1 only. And I think I have to use 2 vectors instead of just one, because there will be 2 DFS calls and it would be returning 2 different vectors, right? So I think I should better do like distance of let's say a, because we are finding it for a, and then the same for b because we are finding it for the b, right? So what does these vectors, 2 vectors represent? So this dist vector represents the distance of Marcel to all the other nodes including the entry point. Similarly, this dist b vector represents the distance of Valerio to all the other nodes including the entry point. So as I just told you in the explanation, that if the distance, if Valerio's distance to the entry point is less as compared to the distance of Marcel to the entry point, if it is the case, then it means that Valerio is able to reach the entry point sooner, right? If he is able to reach it sooner, then we will print a yes, and otherwise if it is not the case, then we will simply print a no, right? Just return it here because it is a void one. If you even if you don't write it, there's no problem. Now let us write this BFS function finally. So since it is returning a vector, I will say vector of int BFS, and here I am passing like first the node from where I am starting the BFS call, then the visited array, and then the actual graph, that is the adjacency list, like this. And what we do in a BFS, if you know, so in a BFS, since we have to return a vector, so we have to construct a vector here which will store the distances. So let's name it dis, and it will obviously of the size n+1. So I guess I also have to pass n here. So here I will just be passing n through both of these functions. So now I have passed n here, and I will just use a queue, just a normal thing that we do in BFS. So let's name it queue, and initially what I will do is I will just push this node that is the starting point in this queue, and then I will set this distance of the starting point 0, that is itself to itself will be 0, right? And then we will run this until our queue is not empty, right? So if our queue is not empty, then let's pop it up from the queue. So it will be like queue.front only, and then queue.pop, just a standard BFS, and then we'll iterate through its children, that is auto child belonging to graph of this node. And if it is not visited, so if the child is not visited, then we'll mark it visited here. So suppose we marked it visited here, and then we'll push it to the queue. So what we have to push, we have to push an integer, that is the child, and I will just update this distance of child is equal to distance of this node plus 1, right? And after that I will just be returning this distance vector. So now I think I have written the code like the DFS function first, which will mark the entry point, and the BFS function for both Marcel and Valerio. Now I think I have written the complete code, that is the DFS for marking the entry node, and the BFS for finding the minimum distance from both of them to the entry point, right? And one thing I think I should do is, before starting the DFS call, I think I should reassign this visited array, that is visited to 0 actually, and it is of the size n+1, right? So I think I should do this like this. So now if I try to run up the code, let's see what happens. Okay, now we are getting the wrong answer obviously. So we find out what's wrong with this. Okay, I forgot to do one thing here. See, since it is returning a boolean value, right? So I should have done it like, if this DFS function returns a true, then I will simply return a true here, right? And I also did a minor change here, like I set the entry point to -1 instead of 0, and added a return statement here because we don't want to go any further once we have found our answer. Now if I run up the code, still getting wrong answers. Let me find out what's wrong with this. So I think I have found what was wrong with the code. So I did a minor change. Instead of using a visited array in this BFS call, I just did what? I just set the distance vector initially to -1 to each and every index, and were going to the child element if and only if the value of that child element in this distance vector is -1. So it means that previously this child was not visited by any other node, right? So the first time it is getting visited, and also the minimum amount of time, right? So that's why we are just checking if the distance c, that is the value stored in this vector for the child, is -1 or not. If it is -1, then it is getting visited for the first time. Then we are setting the distances like this, that is distance of this child is equal to whatever the distance it took us to the node plus 1, because for every age we are considering just 1 unit of time, and then we are simply pushing it to the queue. So yeah, I think now we are getting the correct outputs. And now if I try to submit this code on the platform itself, let's see what happens. So Okay, so we got it accepted AC. So this is the thing we wrote. First we took the inputs NAB and then N lines of input, constructed the graph, just check if A equal to bin, then print a no and return. Otherwise we find a entry point, and then to find the entry point we do a DFS and then do a BFS twice from each of the two persons, and then just check if uh, and then just check if the thief, that is Valerio, can reach this entry point before Marcel, whatever his name was. And if he is able to reach before him, then just print a yes. It means that he is now a part of cycle and can escape him forever, otherwise he is not. And in the DFS call we just did a simple undirected cycle detection check, and we marked the entry point here. And in the BFS, instead of using a visited array, I just used a distance array, because the visited array was getting used earlier in this DFS call, so that might have been giving a problem. So that's why I set it initially to -1, and then just checked if it is -1, so it is getting visited for the first time, so then we are updating it here. And in this way we got it accepted, and I think you understood the solution completely and the code also. So thank you very much for watching this problem and the video, and I hope you understood something better. And if you are new here, please consider liking the video and subscribing this channel, because it takes a lot of efforts to create every single video. And I will also be uploading more and more videos in the upcoming days related to the graph theory and dynamic programming, and also uh, trees, right? So yeah, if you have any suggestions, feel free to write in the comment section. I will read those comments and act on it accordingly. See you in the next video. Thank you.